Thank you very much for coming back.
Our second talk of today will be held by Mr. Sohaib Nadeem. He's working for STRABAG Oman, same as I do. And he's been his position in STRABAG Oman, he's the head of the estimation department. He's been working before in Pakistan, where he also studied. He had been working as assistant director for the Lahore Development Authority and as estimation manager for ISCAR, a Pakistani company. The topic of his talk will be the ADECO approach to tunneling, which will, for the non-tunneling experts here, fill some of the gaps of what we've seen on the presentation of Mr. Speciale already. So he's going more into detail of the basics, the concepts of engineering that are underlying these methods.
Good morning, everyone. I'll be presenting the ADECO RS approach to tunneling, which is a relatively newer approach. And as Mr. Chairman just mentioned, because of the new upcoming projects or mega projects in Oman, so me being not a tunnel expert, I just present this relatively new approach for the experts to discuss which are the better suited methods of tunneling in the condition period in Oman. So what I will be presenting is a short overview of the contents. So what is ADECO RS? ADECO RS approach. This is an acronym for Analysis of Controlled Deformation in Rocks and Soils, which was developed by Professor Pietro Lunardi in Italy. The basic concepts, most of you will already be aware of them, so I'll just go through for beginners like me in tunneling. Similar to a flow of water in a river body, the currents go around an obstruction like a pier. Similar to that, the stress conditions change or realign themselves when a cavity is introduced in a ground mass. So when they realign themselves around the cavity, an arch effect is formed to stabilize. Some basic definitions of what is the medium. Medium is the ground in which the tunneling operation takes place. The action is the set of procedures we employ for excavation, and the reaction is the deformation response of the medium against the action. The same concept shown in the form of a diagram. The action of tunnel advancing in this direction, there will be some deformations. Deformation response will be the reaction, and the medium can be one of the three major types classified as rock type, clay type, or sand. The same concept now elaborated further. We can have one of the three possible stability situations. One is where the arch is formed right next to the cavity, and it is a stable condition, and the arch effect is formed within the elastic range with least form of deformations. The second situation can be where an arch is not formed exactly around the cavity, but it is formed at some distance in the elastoplastic range, and there will be some deformations, and the stability will be only short term. So some interventions are required. The third type will be where no arch effect can be formed, and it is an unstable situation, and a failure is imminent, and the whole cavity can collapse. So the basic types of deformations. The convergence is the deviation from the intended tunnel profile in the cavity. The extrusion is this part where the tunnel face is protruding outside of the intended profile, and the pre-convergence, according to this concept, will be within the tunnel advanced core, so ahead of the tunnel advance. So not in the cavity, but within the advanced core, which is yet to be excavated. So these three types of deformations can cause three types of behavior of instability. First could be in a stable condition, only some loose rock or loose ground can fall. In the second situation, the failure of the face can happen, where spalling is happening at the face due to deformations. And the third is complete collapse of the cavity and the face. So the three fundamental situations of stability are where the face will be stable. So this happens in rock type situations, good rocks and good ground conditions. The second is the stable core phase only in short term. So it can happen in cohesive type of materials. The third type is the unstable core phase situation, where the core phase will fail without any interventions. So what type of interventions can be done? One type is protective intervention. Protective intervention is done ahead of the tunnel core and only to protect the tunnel advanced core. The reinforcement intervention is done to reinforce the rock, the advanced core itself. So the research and development of ADECO RS method was done by Professor Lunardi and his team of researchers. Their main focus was on the deformation response of the rock or the ground conditions. And they analyzed it in great detail. And they employed full-scale experimentation in the site, and laboratory experimentations and numerical analysis. For this, they employed 3D mathematical models. So after their analysis of these deformation responses of the ground masses, they proposed control measures to how to stabilize these conditions. Based on the behavior of the rock or the ground mass, they categorized the material according to the stress strain conditions. They categorized in three categories. First one A, B, and then C. The A would be the stable condition. The B category is the stable core, stable situation only short term. The C category is unstable situation. In A category, you see no significant deformations are happening, neither in the pre-convergence or convergence or in the extrusion phase. Similarly, in B, there are more, and in C, failure can happen even more. So the same concept of category is now shown with pictures of types of rocks. So this would be the category A, where the faces of rock type behavior. This is category B, with faces of clay type or cohesive ground type material. And the third type is unstable sand type or loose ground type situation. So what are the different stages of the ADECO RS approach? ADECO RS differentiates between design stage and construction stage. So the design stage consists of these phases: survey phase, diagnosis phase, a therapy phase, and the construction stage consists of operational phase and monitoring phase. So what is the survey phase? The survey phase is where the design engineer will survey and find out all the geological, geomechanical, or hydrological conditions of the rock mass. And the diagnosis phase will be where the design engineer will categorize what type of material it is according to the behavior categories. The therapy phase will be where they will prescribe what type of interventions are required or what type of stabilization measures are required. So the operational phase will now be where these findings will then be put to use, and it will now start with the construction of the tunnel. The monitoring phase will be where all of these measures are then monitored, and then maybe for fine-tuning the design, they will revisit the design. In the design stage, the survey phase will go, the designer will look for the geological conditions, so for like water, gas, rock burst, tectonic contacts, several geological conditions, karstic conditions. Then in the diagnosis phase, they will classify the length of the tunnel into sections with similar behavior. So similar behavior in the first phase would be for category A. If there is a change in strata, they classify it as C. Similarly, along the length of the tunnel, they will classify. In the therapy phase, they then prescribe what type of measures need to be taken. The measures can be in the form of pre-confinement or confinement. First, we see what is pre-confinement. Pre-confinement is stabilization or intervention in the advanced core itself. So the tunnel is advancing in this direction. We can improve this advanced core is by traditional injection freezing. These are only some of the methods that are listed here. Sub-horizontal jet grouting, as was discussed earlier, and mechanical pre-cutting around the profile of the tunnel, and drainage pipes to drain any water from the inside out. Reinforcement of the ground cavity by using fiberglass structural elements, as was seen in the tunnel in Italy before. The confinement action or interventions are done in the cavity. So pre-confinement, I go back, is inside the core, but confinement action is same like any other tunneling method, especially in NATM, like the short treating of the cavity and the roof rock boards. But one thing additional here is the confinement using the invert. This was also discussed in the previous presentation. In the construction stage now, first of all, if in case of bad soil conditions, pre-confinement of the tunnel advanced core is done. Then excavation of the tunnel advanced core, and then confinement of the tunnel cavity, followed by the final lining. This is a diagram showing the longitudinal profile and the section of fiberglass reinforcement being installed. This is a picture showing fiberglass elements being installed. They can be installed after drilling the holes manually. These are the reinforcement elements. This is how the face looks like after the reinforcement. Then the next step is excavation of the tunnel advanced phase. There are several guidelines or parameters which need to be checked before an excavation method is used, but all of them are already decided in the design stage. So if the rock conditions are good, then we can employ drill and blast technique. Typical drill and blast cycle is shown with drilling and then charging, blasting and defuming, mucking out, then chipping any loose rocks and rock bolting, finally surveying, and the cycle starts over. This is how a tunnel face would look like where the charges are set. A typical drill pattern shown. In soils where pre-confinement action has been done, using fiberglass reinforcement, for example, excavation is usually done by mechanical means. So using a ripper or using a hammer in slightly harder soils. Now, the next step is the confinement of the tunnel cavity. The tunnel cavity can be confined with rock boards in case of good rock conditions. This is a machine installing the rock boards. And then the confinement of the tunnel cavity can also be done by the preliminary lining of shotcrete, which is usually reinforced with the steel mesh or steel ribs. Can also be done with steel fibers. This is the same shotcrete lining with steel ribs embedded inside. This is the casting of the tunnel invert. So the tunnel invert is also used as a method of confining the cavity, because it provides it gives the stability by closing the ring of the arch. So it is important in the ADECO RS method to keep the tunnel lining as close to the tunnel face as possible. Another view. Finally, the tunnel cavity will be confined by the final lining. This waterproofing is installed, and then a slip foam is used to line the final lining. Similar process shown here as well. This would be the final lining in the end. This is a typical section shown with the preliminary lining and the final lining and the tunnel invert casted to close the ring and form an arch, to complete the arch and give more stability to the tunnel. The construction stage will follow, or it happens hand in hand with the operational phase, the monitoring phase. So several instruments are used for monitoring any deformations in the tunnel. Also, the monitoring phase also includes the monitoring of the interventions that we have used. So any deformations or any deviations have happened in the confinement methods that we have used. So even after the construction, when in service, the monitoring should go on for proper planning of the maintenance and safety of the tunnel. These are some of the instruments used for the monitoring phase. Several extensometers, accelerometers, piezometers, strain gauges. Before we go to the next slide, I will just show you the a short video explaining some of these construction steps in the ADECO RS method. Unfortunately, it was in Russian, not in English, so no commentary was available. So I will just try to guide through the first step, where they are mapping or the layout of the fiberglass reinforcements to be installed. They're drilling the holes for fiberglass reinforcements. This is how they look like. So the insertion of the fiberglass elements can be done by machine or by hand. Then they are grouted with a quick setting cement grout. Step 2, excavation by mechanical means. The rock hammer is being used for excavating the tunnel core. Temporary bridges will allow the construction vehicles to pass. Finally, section 5 installation of the waterproofing membrane. That is how it should look like in here. And finally, we see some comparisons with the new Austrian Tunneling Method. So obviously, the proponents of the method ADECO RS, they have some reservations with the new Austrian tunneling method. So they list out what are the differences. So the new Austrian tunneling method only focuses on the convergence of the tunnel cavity, whereas ADECO RS analyzes the extrusion and the pre-convergence in the tunnel phase, in the advanced core. Whereas in control, new Austrian tunneling method proposes only the confinement of the tunnel cavity and does not take into account the stabilization of advanced core. The ADECO RS method gives control measures for deformations in the advanced core and perhaps considered it more of a primary concern. The closing of the arch with the invert as close as possible to the advanced core, which means that partial phase excavation is not permitted in ADECO RS method, as it will not close the ring, as they say. Some final points which ADECO RS method claims that new Austrian tunneling method cannot do, listed here. New Austrian tunneling method, they claim, cannot be used in all types of rock conditions, does not distinguish between construction and design stage very clearly, and is not able to make proper forecasting of costs, because it's a design as you go approach. So the reference for the presentation was the book by Mr. Pietro Ronardi, Design and Construction of Tunnels, for those of you who want to study more on the method, because only a few methods of pre-confinement, etc. were discussed in the presentation. You can refer to the book. Thank you very much.